Here we have 130 quickfire questions for P2. So I'll give this to my students as a worksheet. I'm going to put all these questions up here. If you want to have a go, I'll leave a bit of a pause before I flick through them so you can have a go at doing the questions yourself. If not, I'll just go through the answers. So speed is measured in meters per second, distance is measured in meters, and the standard unit for time is seconds. Speed equals distance over time. What is the difference between speed and velocity? Velocity has a direction. What does a flat line on a distance time graph show? This means they have stopped, so the distance isn't increasing. An upward line is going at a steady speed. How can we work out speed from a distance time graph? That is the gradient of the line. And acceleration is measured in meters per second squared. Here are the next set of questions for you. So there are two equations that can be used to find acceleration. Force equals mass times acceleration, or acceleration equals final velocity minus initial velocity divided by the time taken. What does a flat line on a velocity time graph show you? This is going at a steady velocity. And an upward line is showing acceleration. From a distance time graph, you can work out distance travelled as the area under the graph. Force is measured in newtons, mass is measured in kilograms. The equation linking force, mass and acceleration is one that we just had up there. Force equals mass times acceleration. Resultant force is the sum of all the forces acting on an object. And then how will an object be moving if the resultant force is 0? For a stationary object, there'll be no movement. But for an object that is already moving, it won't change. It will just be going at steady speed. So the stopping distance is made up of thinking distance plus braking distance. What forces against the forward movement of the object? So we can have friction, drag, we could also pop air resistance in there. Give 3 things that affect thinking distance. So you should always say whether they positively or negatively affect thinking distance. So things that are going to be bad for thinking distance is going to be drinking alcohol, taking some drugs, or being tired. Give 3 things that affect braking distance. Again, you need to say whether this is going to be positively or negatively affecting braking distance. So a negative effect could be the road conditions, so poor road, slippery surface. So if there's lots of gravel or if it's icy, and the brakes and the tyres on the car. What is the unit for weight? This is one that always throws people. It is newtons, because your weight is the force that you exert upon the earth. So I've asked for the value and the unit here. So you should remember that gravity is 10 newtons per kilograms. Some of the time they'll tell you it's 10, some of the time they won't. What is equation linking weight, gravity and mass? You don't have to learn these because you will get given them on a formula sheet, but it's very handy that for you to be familiar with everything that's going on. Terminal velocity is when the forces are balanced. So the falling due to gravity is going to be equals the resistance forces, so the drag forces or the friction if it's moving along. And what is the equation for the spring constant? And that is newtons per metre. And Hooke's law says that for something that is elastic, the force is going to be directly proportional to the extension up until a point which is the limit of proportionality, where it's going to be inelastic and basically snap. So work done is measured in joules. What is the equation linking distance, work done and force? Work done equals force times distance. The unit for gravitational potential energy is energy, so it's joules. And what is the equation to find an object's gravitational potential energy? Mass, gravity, height. What is the unit for power? One that always makes me giggle there, watts, and the unit for energy is joules. What is the equation, oh dear, linking energy, time and power? Power equals energy over time. What is the unit for kinetic energy? Kinetic energy again is just in joules. And the equation to find kinetic energy is half mass velocity squared. What is the unit for momentum? This is another one that throws people sometimes. It's kilogram meters per second. Momentum can be calculated. This is a P for momentum, not to be confused with P for power. It's mass times velocity. The law of conservation of momentum says that the momentum before is going to be equal to the momentum after. We can't lose momentum anywhere. So how does increasing impact time affect the force? So the longer something takes to impact, you're going to get less force. This is why we have crumple zones in cars and things like that. So if you are in a car crash, it's going to be safer because the crumple zone, the massive bonnet at the front of the car, is going to absorb some of the force. Where can we find protons and neutrons? These are in the nucleus. Where can we find electrons? These are in the shells around the outside. Proton has a 1 plus charge, neutron is neutral, and the charge of an electron is -1. So here we have a cell, here we have a switch, that's an open switch, and this is going to be a closed switch here. Lots more drawings going on now. So a diode, an LED, this is just a type of diode, an ammeter, a resistor, a variable resistor, fuse, a heater, a voltmeter. Current is measured in amps, potential difference is measured in volts. Nearly halfway through now. So charge is measured in coulombs. The equation linking them is I is Q over T. The equation linking charge, work done, and potential difference is work done over charge. Resistance is measured in ohms. That can also be written like that. And the equation linking things up is V equals IR. So an ammeter should be connected in series and a voltmeter should be connected in parallel. So Ohm's law is just this equation here, showing that there is a linkage between the potential difference and the current. So a potential difference for a filament lamp is, I'm just going to sketch that up here, going to look like this. So the current potential difference graph for a diode is going to be, let me just pop that on a different colour, flat line across there and then going up. So the current potential difference for a thermistor is going to look like this, and for an LRD is going to be basically the same. In a series circuit, how does the current change between each component? So these are the same, which can just be written that the current is going to be the same through each of the circuits. Slightly different in a parallel one, where it's split across them. So in a series circuit, the resistance is going to be the sum of all of the components. But in a parallel circuit, it's going to be the same. So DC is direct current, that is just going in one direction. AC is alternating current. Which means on a oscilloscope for a DC you're going to see a straight line, whereas for an AC you're going to see it going up and down. The frequency of electricity in the UK is 50 Hertz, and oscilloscope measures traces of things, so this can be current or this can be sound. So sketch the inside of a plug to show the location of the 3 wires. I'm going to have to draw a very, very small sketch for you here. But the basic thing you need to know is that we have our fuse here. This is going to be our live wire. Our earth wire is the one that comes over here, and then our neutral wire is the one that comes here. So this is neutral, this is earth, and this is live. That should be Y. Our plug socket's made of plastic to insulate it. And again, wire mains electricity is surrounded in plastic to insulate them. What does the earth wire do? It takes any excess current and sends it to the earth, so it is a safety feature. So the fuse is just a very thin bit of wire, and if too much current goes through it, and then it will snap or it will blow. So it stops the current, it stops the flow. So once this wire breaks, then the current can't flow anymore. So an RCCB is just a really big circuit breaker which will do the same thing. So it protects you from too high current. So the advantage of an RCCB over a fuse is that a fuse has to be replaced and an RCCB can just be turned back on. Couple more equations now, so linking power, current and potential difference. Potential difference, charge, and just checked that is energy, and this one's for the higher tier only. So the 2 types of radiation are alpha, beta and gamma radiation. This is a symbol for alpha radiation. Alpha radiation is also known as a helium nuclei. An alpha particle is made up of 2 neutrons and 2 protons. The symbol for beta radiation is this, and beta radiation is also known as an electron. 2 sources of background radiation: you could have radon gas from the Earth, You can have cosmic rays. Those are the most common ones. You could also have X-rays, or maybe your local nuclear power plant. What are protons? Or where are protons? They're in the nucleus. Protons, nucleus. Neutrons, nucleus. Electron shells are in the shells from that side. I apologise, this appears to be a repeat of a question, but revision is good revision. So mass of a proton is 1, electron is 0, neutron is 1, charge on a proton is +1, 0, -1. How can we tell the mass of an element? That is the mass number on the periodic table is the larger number up at the top. So we can tell how many protons an element has by looking at its atomic number. That's going to be the little one down in the bottom. Neutrons is going to be the mass number minus the atomic number. An isotope has the same number of protons and electrons, but a different number of neutrons. So thorium-228, we're going to need to use a periodic table for this. And then we need to have 4, 2, because this is alpha decay. So 228 minus 4 is 224. 90 minus 2 is 88. So looking at our periodic table, we can tell that after alpha decay it's going to be radium, sorry. So thorium-228, 90 again, minus beta decay, which is 0 minus 1. So 228 minus 0 is 228. 90 minus 1 is 91. So that is going to be protactinium. What is an alpha particle's range in air? Not very far. It is about 10 centimetres. What can stop an alpha particle? Paper. Beta particles have a long range, but they can be stopped by thin sheets of metal. Gamma particles have a very long range. So what can stop gamma radiation? For this we are going to need a thick lead-lined box. Half-life is the time it takes to decay to half. Why is it radioactive to help its rate? Because it's a completely random process. Alpha radiation can be used in fire alarms. Beta radiation can be used in medicine, or to detect thickness of foil being made. Gamma radiation can be used in medicine as well. What is carbon dating? That's how we tell the age of something by the number of carbon particles. And what is nuclear fission? This is breaking up nuclei. Nuclear fusion is fusing nuclei together. So a low mass star is going to be a protostar. Then it is going to be a main sequence star. Then a red giant. Then a white dwarf. Then a black dwarf. A high mass star starts off the same, so it's a protostar. And a main sequence star. But then is a red supergiant. And goes supernova. And then either becomes a black hole or a neutron star. So main sequence star is the majority of the life, and that's where nuclear fusion is taking place. Describe the forces inside a main sequence star. These are going to be balanced forces. And how are every heavy elements formed? This is in supernova. Are you going to do amazing well in your physics exam? Of course you are, because you've been working really hard. Thanks for watching. I really hope this is helpful. Subscribe so you don't miss any of my new videos. Share to help your friends get better grades. Any comments, corrections, questions or requests down below please.